equal to 0. That's all. When y is equal to 0, x is equal to 0. And sometimes, like if you notice, sometimes it's easier to go back to this one. If I'm going to have y equals 0, I can take both of these out and just deal with that piece. I wouldn't, maybe the x equals to 0, maybe that will help you and you can factor it or do something else. I really wouldn't go through the quadratic on that part. I'd probably do more this format for that one. Use whichever one you find is easier to work with. The square I wouldn't work with. I'd work with the other form of it. But if you're going to get rid of the both y's, then that one's easier. So remember, your goal is to complete the square to set this up to be one of those standard forms. Look for the square. This square is y. So I'm going to use this format. So get your y's to one side. Start like that. Get everything else to the other side. You only have one square to complete the square. So set this guy up with a little space so that you can complete that square. Half of 6 is 3. Then you do 3 squared, 9, and put the 9 on the other side. You have an equal sign. That has to stay equal. This is your y plus 3 times y plus 3. That's where your perfect square comes out. You made that. Collect these like terms. And now, you still notice this is a little bit off. I need x minus or plus something, but I need x by itself. So I look to see what its coefficient is, and I factor that out. So factoring it out, remember if I divide a negative by a negative, I get a positive. And here is my equation. From that, I can find my vertex. My vertex is my h, k. There's my vertex. Remember, it comes out the opposite way, just like your circles. Because you're really saying negative h is equal to 2, therefore therefore h is equal to negative 2. You can set this up. I would take this piece right here and line this up. You're going to line this up like this. Therefore, you know your vertex. Therefore, you know RP is equal to negative 8. Find P. This is the most important thing. P is the distance from your vertex to your focus and the opposite way to your directrix. Now, if P is negative and it's a y squared, it's going to open left. That's important for you to know when you start to sketch this. So you sketch its vertex first, negative 2, negative 3, and then you open this thing left. Okay? Now remember, your parabola encompasses your focus. So your focus is inside, your directrix is a line outside. It's kind of easy to remember. There's no other place to put that directrix line. You can't cut through your parabola. It can't be lengthwise that way, so it's got to be that vertical line in this case. Do you have to use your formulas? No. Use your diagram. If you're coming across this way, say to yourself, I'm changing the x. I need to go 2 positions to the left of me. So instead of negative 2, I'm at negative 4. Same y. There's my focus point. It works the same way with your formulas. Go 2 the other way. If I'm here at negative 2, then I'm negative 1. Oh, I'm at the 0. This is when x is equal to 0. Here's your directrix. If you need to use the formulas, you have to memorize them. I personally wouldn't, because you're dealing with a lot of like the same letters. And then you have to remember which one is which. So it's easier just to take it right off your graph. Now, your intercepts. Donovan's favorite part. When x is equal to 0, when y is equal to 0. Now, I use this form both times. But, like I said before, if you're doing y equals to 0, this one might be easier. It's up to you. Y equals 0 would take this out and take this out, and you have a nice little equation to solve. It's up to you. I would really not do the x equal to 0 because then you're going to get a quadratic that if it's not factorable, you have to use the quadratic equation, which is too complicated. Come back down here to your standard form and plug it in here. Once you get to this point right here, you should be able to see, oh, this is giving me a negative. I can't take the square root of a negative. And doesn't that make sense? I have no real y-intercepts. Did it ever touch my y-axis? No, I have no real y-intercepts. Make sure your graph makes sense. If you find one of your intercepts and it can't possibly fit to your graph, something's wrong. Take a look at it. Anybody have any questions? You weren't here yesterday, right? Anybody else not here yesterday? Okay. And Alicia. Oh, okay, but what we're doing basically, only difference from the day before is completing that square. We're completing the square, and then everything else is the same as the day before. Once we hit this format, this guy right here, it's the same as the day before. Completing the square, you only get one square to complete. That has to be on the left-hand side. Complete that square, and then you get your standard form. Okay, if you didn't have it, you should be writing this down. Yes.
What if you subtract y squared and like negative over the 6y and y is 1%?
Okay, but don't forget your y squared is going to have to be positive. You have to divide by a negative 1. Yeah, you got to keep that positive over here, as well as in here your x has to be positive. And you can just remember to divide by a negative 1 at the end. Okay, next one. Okay, you have a y squared. So which way is your parabola going to go? Up and down or left and right? Left and right. It's got to be left or right. So we don't know yet because we don't know what p is. So, guys, come on. Get your y's together. You want this format. You want that format. So get your y's over here. That's where you should see I have to complete the square. It's my only square there. So put your space out here. Add 4x to that side. Half of negative 4 is negative 2. Because y minus 2 times y minus 2 gives you that trinomial. That's your square. This guy, add 4. Remember, the x has to look like this with the 1 in front of it. So factor out whatever happens to be in front of x. Factor it out, and now you've got your setup. Y minus k squared equals 4p x minus h. Pull out your vertex. Comes out the opposite way. 4 is equal to 4p. Find p. God bless you. So if you know p is positive, and Chris told us it goes left or right, so now I know it goes to the right. When it's positive, it goes towards the positive numbers. When it's negative, it goes the opposite way, towards the negative numbers. Okay? I start like this. Find your vertex. Remember, you're sketching. Don't make your little tick marks. Just sketch it. Now, sometimes it's nice to do this. P is 1. It's got to go one that way, one that way. That'll kind of help you. You're going this way, so you're changing your x. So if this is at negative 1, and you're going here, brings you to the 0. There's the 0 too. If you're at negative 1 and you're going to the left of it, you're at negative 2. You're at negative 2, 2. Even if you just found this point right now. When you do this line, this is the x equals. So take the x value and put it right in there. If you go point to the left, point to the right, then just build your directrix formula off of that point. If it's a y equal, you take the y value. If it's an x equal, you take the x value. And again with the intercepts, now you got x and y intercepts. When you come down here, if you want to do the y-intercepts, get rid of that. You can tell right here that the x is going to be a 0. And your x-intercept was a 0. You only had 1. It passed through the 0, 0. So I crossed at the 0, 0. My y-intercept is also going to show me a 0. because that's where your y-axis is too. When you take the square root, it's most important to remember you have a positive and a negative when you do the square root. And work that out. Don't leave it like that. Work it out. You can leave it if it's a radical. Then you can't go with it anywhere else, but make sure you work it out. And it kind of makes sense. You know the 0, 0 had to be one of them, and you can kind of judge by that. If it came down to, it's got to go up to, well, off of your vertex. You can almost see, if you make sense out of these, I think you have a much, much better chance of understanding them. Step back and like analyze what you got. See what it looks like. Before I even did the intercepts, if I knew this was one of my intercepts, and this is 2 over here, well, it's symmetric, isn't it? It's got to be 4. So if that didn't work out, then something went wrong. And don't leave it. Look for the mistakes. Questions? How do we get rid of this fraction? Multiply by 4. Get rid of your fraction. Then you notice you have x squares. So x squared means you're following this one. So therefore, get the x's to one side, get everything else to the other. I swapped this first so that I could keep my x on my left-hand side. Then I subtracted 5. I subtracted 5, and there it is over here. Complete the square. Half of -2 is -1. 1 squared is 1. 1. Get rid of this 4 in front of the y. Factor it out. Then you can figure out where this is opening. It's an x squared. It goes up or down. If p is positive, it goes up. Just like your old beloved quadratics. Your focus, your directrix. I really think if you use your graph instead of anything else, it's easier. If you're moving vertically, you're only going to change your y value. So if you're moving up 1 and down 1, look at your y's. So to move down 1, this is going to be at the 1, 0. To move up 1, this is going to be at the 1, 2. Now, because this is a y equal, use the y value. Your directrix is a line. I kind of made my dotted line above your axis just so that you could see it was right on your axis. And your intercepts. You can tell right there we're not going to have any real x ones, right? So when we get down here, and this gives me a negative, I can't take the square root of a negative number. This is already set up y equal. You might want to throw your x of 0 in here. So x is 0, and 5. Y is 5/4. How easy was that intercept? Was that easier to do than this whole thing over here? Yeah. Use whatever form is easier for you to use. But you should know how to plug in an x of 0 and a y of 0. Both forms have to give you the same parabola. Okay? Questions? Can we do these? I'm getting yes and no and maybe and not and kind of quiet. Alright, I'm going to take this guy out of here a second. And I'm going to go to this one. And we're going to work this one all the way through. Okay. We're going to work 74. Did I give you that hint on your paper?
Yeah.
What a nice teacher I am. Okay. So we multiply through by 4. Let's work this out together. So it looks like this. What one is my square? Y. So right away I know I'm using this. I'm using this. I want you to set this up so that the y's are on one side and the x in the number is on the other side. Go ahead. Set it up. I want the y's on one side and the x and the constant on the other side. You didn't get this last night, do this now. So if I move these y's to the other side, and then I just reflect this, did you get that? Stop me if you didn't. I added my y square and my 2y to this side. So they both became positive. And I was left with 4x minus 33. And then I just swapped their sides. I notice I need my y squared on my left-hand side. Now that's where my square is. So we're going to make a space and complete the square. Oops. So what's my next step? Aaron. Yeah. Okay, so what's half 2? 1. Double it. Square it.
Or you square it and then make that 1 on each side.
1 on each side. So what's this side equal to? Okay, we're almost there, but I know I need x by itself. So what's in front of the x? So I got to factor it out. What am I left with? Minus 8. Now, this is where you need to know this format, because you need to know where your p is. So what's my vertex of this guy? 8, negative 1. Okay, what's my p equal to? 1. Does everybody see 4p is equal to 4? Therefore, p is equal to 1. Which way is my parabola opening? To the right. It's a y squared and p is positive. So I locate 8, negative 1. And it's opening to the right. Where do I find my focus? Inside or outside?
Inside.
Inside. And my directrix? Outside. So P is 1. I got to move 1 unit horizontally, which is going to change the x or the y. Yes. So what's this point going to become? If I was at 8 and I got to move over 1, 9, negative 1. We just found your focus. Now, I got to move 1 to the left. 7. So even if you did this, 7, negative 1. Now this guy is an x equal. What's this x value? 7. This is my directrix. The directrix is a line. Yes?
How come the vertex isn't negative 1?
Because it goes like this. Circle this part. Negative 8 is equal to negative h. So you have to solve for h. So you're going to divide by negative 1. It ends up coming out the opposite way. It's the same setup that we use for your circle, with the x minus h, y minus k. That's why it's very confusing. If you look at this one, Aaron, negative k is equal to 1. I got to solve for the positive k. Okay? Yeah. We've got everything except our intercepts. So, I'm going to cheat. This is x equals, right? I'm going to take my y's of 0. I'm looking for my x-intercept. I'm going to use this one. Out comes this, out comes this. So I've got x is equal to 1/4 of 33. 33 fourths. Here's where I cross the line. Now, if I divide 4 into 33, that's just a little bit bigger than 8, isn't it? If my vertex is at 8, it just means my parabola is very wide. This is the point that I crossed. I only had one x-intercept, right? Now, for my y-intercept, guys, x is 0. I'm going to use this one. I'll go to this one. I'll decide to do that one. Y plus 1 squared equals 4x minus 32. Do I have to use the one that I factored? No, because I'm going to end up distributing it anyway, right? So I'll use the one right before it. So x is 0, so this becomes negative 32. I take the square root and I say, whoops, no real y-intercepts. And did my graph ever touch that y-axis? Nope, no real y-intercepts. Can you do this? Okay, I want everybody to do this next one. If you didn't do it, I want you working on that right now. Okay, let's go over this, guys. So, we agreed that it's an x squared, so we're putting the x squared on one side, and we're moving the rest of the stuff to the other side. Now, it's going to follow this format. Okay, so I have to complete the square. I need that square out of my square thing here. So I'm going to leave a little space to complete the square. If you add to one side, remember you have to add to the other side. So now, what's half of 4? 2. This is where you build your perfect square. What's 2 squares? 4. Now, that factors into x plus 2 times x plus 2. See how you got your perfect square? X plus 2 squared. We made that perfect square. Now, collect your like terms. You notice that y has to be positive, so whatever is in front of this, factor out. Now, if it helps you, put your formula underneath it. I actually think the formula helps for the p, because then you forget to do the p. If you forget the p part, you kind of are going to get stuck on your focus and your directrix. So what's your vertex for this guy? Negative 2, 1. Notice it comes out the opposite way. And negative 6 is equal to 4p. So I'm going to reduce this. So p is equal to negative 3 halves. Negative 3 halves is just negative 1 1/2. So we graph. Negative 2, 1. There's my vertex. Which way is my parabola opening? Down. My p is negative, and I have an x squared. Down. Okay? Now, work this out. You're going to change your y when you come down. I'm at 1. I'm going to come down 1 1/2. So this is negative 2, negative 1/2. See it? That's my focus. I'm going to go up 1 1/2. I go up 1, I get to 2. I go up 1/2, I get to 2 1/2. So y is equal to 2 1/2 or 5 halves. Okay, and your intercepts again, when x is equal to 0, take those out and solve this. 6y minus 2, add 2, and divide by 6. Y is equal to 1/3. So it's going to cross a little bit over that top. And do your x-intercepts when y is equal to 0. Use this. Guys, 1 minute.
So I would just so like calculate on a graph too.
You can't graph this on the calculator. So this is coming out. So therefore, when I take the square root, you get a plus or minus. Guys, I need your attention. Now, you can leave your intercepts like this, comma 0, because you can't really reduce radical 6. You can't reduce it any more than that. So one's coming here, one's coming here. The focus is at 2, -2, -1 now.